Hey everyone, this is Lucas Wilkerson, the math coach from FGCU. Today we're going to do a couple of problems on section 5.1, 5.2, and 5.3. Let's get into it. I'm going to look at question number 1. It says solve the system by the substitution method. When it says solve by the substitution method, what it wants us to do is get everything on one side. So for example, let's look at the first equation. We can subtract 3y from both sides, and we would get negative 2 minus 3y. And now we have what x is, and we can look at the second equation and just plug in what we found for x in there. So it'd be 5, and then instead of times x, it'll be times negative 2, negative 3y, plus 4y, minus 10. What this allows us to do is now we only have one variable that we can solve for. We can, let's see, we can multiply the 5 then our y's can simplify to negative 11y. We can add 10 to both sides, and then divide by 11, and we're left with y equals 0. Once you find y equals 0, or just whatever y is equal to, we're going to want to take it and plug it in up here for what we found x was equal to. And when we do that, we're going to get x equals negative 2 minus 3 times 0, which means x is negative 2. So our answer would be negative 2, that's our x value, and then 0, which is our y value. For number 2, we're going to do the same thing, except we're going to solve the system of equations by the addition/elimination method. When we do the addition/elimination method, what we're looking to do is add the two functions together, but we need a variable to cancel out. So if you look at these, we don't have any matching variables. We have x's and y's, but they're all being multiplied by different things. So we're going to want to multiply them both by a factor that'll make them equal. So here we're going to use 4, and we're going to use 5. And I'm just look at the top equation, how we have 5y, and the bottom one, how we have negative 4y. I just chose the respective opposites. That way they'll equal each other in their y values. So this turns into 8x plus 20y equals negative 68. Then we get negative 35x minus 20y equals 25. When we add these together, we notice our y values cancel out. We get negative 43x is equal to 43, which means x is equal to 1. And then I'll just choose the first equation to plug x back into. We'll get negative 2 times 1 plus 5y equals negative 17. Negative 2 times 1 is just, you guessed it, negative 2. Everything else stays the same. We can add 2 to both sides. Divide by 5. Then we get 1 comma negative 3. Next question, number 4, is a little bit of a story problem. It says the Family Fine Art Center charges $24 per adult and $12 per senior citizen for its performances. On a recent weekend evening, when 541 people paid admissions, the total receipts were $8,676. How many senior... Oh, I'm going to sneeze. Nope, I'm good. Sorry, I thought I was going to sneeze. How many senior citizens and adults went to the performance? So, like most story problems, we want to highlight key information. It's $24 per adult, 12 per senior citizen, 541 people, and their receipts were $8,676. Let's call the adults X and the senior citizens Y. And since we know, let's see, You know the amount of people is going to be x plus y is equal to 541 because we were given that the total amount was 541. So that means if it was $24 for an adult ticket and it was $12 for a senior citizen ticket, their total receipts added up to $8,676. This is useful because if we have two unknowns but two equations, we can figure out for both of them. So the simplest method is going to be looking at our second equation and just using the substitution method. We'll subtract y from both sides, and then we plug it back into the first equation, which gives us 24 times 541 minus y plus 12y equals 8,706. Multiply this out, and we'll get this. Nice fun big numbers. Combine the y's, and then we'll subtract the 12,000 number from both sides. Divide by -12. Now that we found y, we can plug it into this equation we found. So plugging it in there, and we get x equals 541 minus 359, which means x is 182. Now if we look back at our problem, we see x is the amount of adults, so 182 adults, and 359 senior citizens. Looking at section 5.2, we have this nice ginormous problem that says solve the system of equations, but we're given 3 equations. So just to preface, this is going to be a long chaotic one. The way I'm going to do this so you guys can follow is I'm going to label the first equation A, this B, and this C. This doesn't have anything to do with, like, we're not multiplying it by A, B, and C. I'm just labeling these equations, so if I say equation B, you know which one I'm talking about. So to do the first thing, let's try and eliminate y will be the easiest. And so we'll take equation A, subtract it from B. We'll also take B and add it to C. Or actually, we're going to add both of them. So what this looks like is x plus y plus z equals 1. X minus y plus 5z equals -1. I'm going to take x minus y plus 5z equals -1. 3x plus y plus z equals -5. And we're going to add them. Looking at the left set of equations, we're going to get 2x. These cancel out. We get 6z, and it equals to 0. We're going to call this equation D. Looking at the right system of equations, we get 4x. These eliminate. Then we get 6x. Or 6z, my bad. And it's equal to -6. We're going to call this equation E. And then we're going to want to take D and E and eliminate the variable z. If we try and add these, we won't be able to eliminate z. So what I'm going to do is this top equation, I'm going to take I'm going to multiply it by -1. And that gives us -2x minus 6z equals 0. 4x plus 6z equals -6. We can add these both together, and we get 2x. These eliminate. Equals -6. Divide both sides, and we get x equal to -3. And we finally found a value. So now that we found x, we'll look for a system to plug it into where we can find another variable. So I'm going to say, let's plug into d. We could choose d or e, because there's just two variables. We're going to get 2 times -3 plus 6z is equal to 0. This comes -6 plus 6z equals 0. Add 6 to both sides, 6z equals 6. Divide both sides by 6, z equals 1. Now we just need to find y. So we're going to plug into a. We plug in the -3 we found, plus y, and we plug in the 1 we found. It's equal to 1. Solve this, and we get y is equal to 3. So our points that we found are -3 for the x, 3 for the y, and 1 for the z. Not the most fun problem. Looking at section 5.3, we work with partial fraction decompositions. It says write the partial fraction decomposition of the rational expression. When we go to do partial fraction decompositions, we need to look at our denominator and determine if it's a linear or a quadratic. Here, the highest x exponent is just 1, so we can say that both are linear. Since both are linear, we can set up the denominator as a and b. And there's two pieces because there's two things being multiplied in their respective denominators. Then, how do we want to set this up? The denominator of a will be the first thing, x minus 1, and the denominator of b will be x minus 5. And we need to set it equal to the equation we had. To simplify this, we're going to want to multiply both sides by the denominators. So it's going to be x minus 1, x minus 5. Then I'm going to cram this in here. X minus 1, x minus 5. What that's going to allow us to do is, looking at the left-hand side, we would be left with a x times 5 plus b x minus 1, and the right-hand side would become just 6x minus 48. Now we're just going to FOIL each piece out. Get ax minus 5a plus bx minus b is equal to 16 minus 48, 16x minus 48. We want to get the x and the constants by each other, so we can reorganize it like this. And then we can take out the x from these. And then we can solve it in pieces. So if we know this is the x piece, it is going to correspond with this x piece. And if these are the constants, it'll correspond with this constant. So then we can set it up as, looking at the x, we have 16x is equal to x a plus b. Since they're both being multiplied by x, we don't have to worry about that, and we can set it up as 16 equals a plus b. Our constants are -5a, -b, they're equal to -48. So it would look like this. Now to solve, we can just add them and the b's will cancel out. Left with -32 equals -4a. Divide, and we get a is 8. We can plug in to that 16 equals a plus b, and it'll be 16 equals 8 plus b. Solve this, and we find b is also 8. Now we'll do an example where the denominators are not linear. In this example, we're going to see the denominator is a quadratic. When this happens, it's going to look a little bit different. And so we know we're going to have the piece that they gave us, this 3x cubed plus 23x minus 6, x squared plus 6 squared. And then it's going to be equal to, we started with ax plus b, and the denominator will just be what's in the parentheses. So x squared plus 6, and then we'll add it, since it's a quadratic that's squared, to cx plus d, then what's inside the parentheses, and its square. To solve and simplify this, again, we just multiply both sides by the denominator. Working through this, that denominator cancels out. On the right-hand side, we're left with ax plus b times x squared plus 6 plus, let's see, cx plus d, because that denominator cancels out all the way. And then again, we're just going to organize them by the exponents. So we would FOIL this out. Once you FOIL it out, you're going to get ax cubed plus 6ax plus bx squared plus 6b plus cx plus d, all equal to this. And then we just want to reorganize it so that the leading exponents are as left as they can be. Ax cubed plus bx squared plus 6a plus c times x plus our constants 6b plus d. Now looking at this, we can match up each piece. The bx squared doesn't have any piece, so that would just be equal to 0. Now, looking at this, we see the ax cubed is just going to be 3 equal to a, so we found that piece. B doesn't have any piece it connects to, so we can say 0 is b. And then the 6a plus c times x corresponds with the 23x. That changes to 23 equals 6a plus c. And then the last piece, 6b plus d, corresponding with negative 6, gives us negative 6 equals 6b plus d. And if we plug in the a and b values we found, we can change this to 23 equals 6 times 3 plus c. We'll solve this and we get c equals 5. For the bottom one, plug in the b value we found, negative 6 times 0 plus d equals negative 6. Rearrange this and see that d is equal to negative 6. And sometimes they might ask you to plug it back into the original equation. If they ask you to do that, your answer would look like this. And that's it.